Hello everyone. Today we're going to be discussing diversity and how this relates to the design of a cooker circuit. We'll look at what diversity is and why we use it, and then go through some calculations based on a cooker circuit for some practice. What is diversity? Diversity is the figure applied to a cooker circuit to determine the realistic amount of power you are likely to use at any given time. There are other circuits as well that diversity can be applied to, and these can be found in Appendix A of the on-site guide in Table A1. For this demonstration though, we'll focus on cooker circuits. We apply diversity to circuits at the design stage so that before installation begins we can be sure that we have selected both a cable and a protected device that is suitable for the circuit without unnecessary overkill for both of these items. The regulations will still be met after diversity is applied, so long as it has been done correctly, and this ultimately will save money for the customer by not having to pay for excessively large cable and circuit breakers, and will save you time as an installer, as the cable will potentially have a smaller cross-sectional area and will be easier to work with throughout the property and at terminations. Firstly, we'll calculate current by using PIV. Domestic appliances have a power rating, typically in kilowatts or kilowatt hours, which can show how powerful or economical they are. If you have a large double oven and a multi-ring hob, the amount of current it can draw will be relatively large, at least in terms of an average domestic setup. It will be sold, for instance, as a 12 kilowatt oven, which is 12,000 watts. We can use this in PIV to calculate current, as we know our nominal voltage to be 230 volts. To put that in a formula triangle, you'll have your power at the top, which is 12,000, and voltage on the bottom right, which is 230. We'll then divide the top by the bottom to find the missing value, which for this will be your current. This will give us a current of 52.17 amps, which is enormous, especially if your main switch rating in your consumer unit is only 63 amps. Your cooker will potentially use over 80% of your available power if it is turned on and running at full output. The point of diversity though is that it is a fair assumption that you will not have every oven and grill turned up to maximum and every hob turned on fully all at the same time, and this is where our calculations come in. Bear in mind that this figure of 52.17 amps will be different for cookers with a higher or lower power rating, but it will be calculated with P over V as before. Firstly, we're going to take our current of 52.17 amps as our starting figure for this particular cooker. We're then going to deduct the first 10 amps. Removing these 10 amps is applicable to all cooker circuits at the design stage, and we're going to place those 10 amps down here at the bottom of the screen. What we're left with is a remainder of 42.17 amps. The on-site guide, Table A1, states that we need to find 30% of this remainder, and we can do that by multiplying it by 0.3. This gives us a figure of 12.65 amps. All we need to do now is add our 12.65 amps to the initial 10 amps we deducted at the start, and we have a result, after applying diversity, of 22.65 amps. This means that the circuit can be placed on a 32 amp miniature circuit breaker rather than a 63 amp as it would have had to have been at the start with our 52.17 amp current. This in turn will allow for smaller cross-sectional area cable to be selected for the installation, as found in Appendix F in the on-site guide. This of course is without any relevant cable factors being applied to the design, which we can now determine as we have a design current, an IB, of 22.65 amps, but we'll cover cable selection in another presentation. It's worth noting for these calculations and for your exams that a cooker switch with an integrated socket outlet will increase your design current by 5 amps. So if a cooker switch with a socket outlet was to be installed on the circuit we've just calculated for, our design current would then be 27.65 amps.